Imagine you are sitting on your couch, you pull out your phone and type a text message to a friend and hit send. And in less than a second, it appears on their screen potentially halfway across the world. We do this dozens, maybe 100 times a day, but have we ever stopped to wonder how? How does that tiny little packet find its way from your device in hand to that one specific device out of billions? Feels like magic, huh? Believe me, it is not. It is due to the most amazing and beautiful system in play behind the scenes that makes sure all your text message reach to that one person reliably. And we call this system the internet. Okay, so before jumping directly to building the server, let's first understand how the internet works. We will not go into much depth, but we will definitely try to cover enough of each area to give basic understanding of the concepts involved. So, what is the internet? In simple words, the internet is network of the networks. Let me break it down for you. In networking perspective, a network is a group of end systems such as mobiles, laptop or server that are connected with each other to share the information. Let's take an example of your home Wi-Fi network. Your laptops, cell phones and smart TV all connected to same Wi-Fi make a tiny network. In your university or office, there are multiple devices connected with switches, and multiple switches are connected with each other to create a much bigger network. Now imagine millions of these networks globally. So the internet connects all these networks together to do one single job, which is to let one end system talk with another end system reliably. Now, naturally, the thought occurs, how do all these different networks made by different companies using different pieces of hardware all agree on a single way to talk? The answer to this question lies in the one of the most powerful ideas in computer science called the protocol stack. This protocol stack is necessary for every device connected to internet to talk to each other. This stack is like set of layers that work together to send data from one computer to another, and it is built in every computer's operating system but is abstracted for users. Now, abstraction might sound academic, but it is nothing but breaking down the complex problem into smaller, manageable parts and hiding the unnecessary details from users. We use abstraction in our day to day life. When driving a car, we use steering wheel and pedals. We do not need to think about how engine works or about fuel injectors or the timing of spark plugs. The car engineers have abstracted all these complexities away, giving us a simple interface to work with. The internet works exactly the same way. This complex information delivery system is abstracted for user by breaking it down into layers where each layer has one specific job, and it relies on layer below it without needing to know the nitty-gritty details of how the other layer works. Let's try to understand this with a demo. We will trace what happens when you type www.cnn.com in your browser to see the latest news. When you type the URL and hit enter, your request for homepage starts at the top of the protocol stack on your computer. It is the layer where web browsers like Chrome, Safari, and other applications like WhatsApp live. Its job is to craft an actual message. In our case, get slash http slash 1.1, which is just a pragmatic way of saying that, hey CNN, send me over the homepage containing the news. This request is now handed down to transport layer, which is our second layer. It adds its own identifier to message containing the port number. By convention, it is almost always port 80. If the message is very long, this layer chops it up into smaller numbered chunks so they can be easily transported and are reassembled at the other end. It also puts a note on it saying, when this packet arrives, please send me a confirmation back so I know you get all the packets. This is the TCP protocol at work, ensuring nothing gets lost. We will talk about TCP in more detail in few moments. Now, these chunks are passed down to the network layer. This layer also adds its own identifier which contains the IP address of CNN. For now, just assume that it somehow knows the IP of CNN. An IP address is like the street address of the house. At this layer, the message is called a packet. This message containing both port number and IP is passed down to the data link layer, which adds a temporary address for very next router in the network. It also encapsulates the packet received from the upper layer before sending it over the network. And lastly, the physical layer converts the whole packet into pulses of light for a fiber optic cable or electrical signals for an Ethernet cable and sends it on its way. When these signals arrive at CNN server, which is also connected to internet, the same process happens in perfect reverse. The physical layer turns the light or electrical pulses back into digital packet. The link layer checks the local address, removes it, and passes the packet up. The network layer sees the destination IP address and says, yep, this package is for this server. It removes the IP header and passes the contents up. The transport layer sees the destination port 80 and says, yeah, this is for our web server. It takes all the numbered packets, reassembles them in correct order, and presents the original complete message to application layer. And finally, the reassembled message, our original GET request, is headed up to the application listening on the port 80. Now we know how a packets get prepared, transmitted to internet, and navigate its way effectively to the recipient. But here is the beautiful part. When we sit down to build our own server, we do not need to worry about programmatically converting packet into electric signal or how it hops between the router. Our job as a developer starts at the very top of the protocol stack. We just need to understand the two most important protocols that define and control how the conversation happens between the client and server over the internet. The first protocol is HTTP, which is the protocol of the application layer. It is the vocabulary our server needs to understand. When a browser sends GET, POST, or other commands, it is speaking HTTP. Our server's main job will be to listen for these HTTP messages, understand what they are asking for, and respond with an HTTP response. It is literally the language of web. But the HTTP on its own is nothing but a set of words which doesn't know who to navigate to across the complex internet infrastructure. This is where the second protocol called TCP steps in. This protocol is associated with the transport layer and ensures the reliable delivery of messages across the internet. Before a single HTTP message is sent, TCP steps in to establish a stable connection between the browser and our server. It then takes the HTTP messages, ensures it gets there in right order without any missing chunk, and even waits for the confirmation. It is this engine that makes the conversation reliable. Key takeaway here is that HTTP and TCP work as a team. HTTP defines what to say, and TCP handles how it gets there reliably. You cannot have modern web conversation without both.